Mathematically speaking, when the position of an object follows a rule, its path is known as a locus. The plural of locus is loci. It might sound like an odd word, but locus, forward, and loci come from the Latin word for place. And today's Maths for Real brings you the lowdown on loci, helping you to recognise the different types of loci and how to draw their paths. Come on, let's go.
The first type of locus we're looking at is based on a fixed point. And the rule is this. I have to be a fixed distance from this point here in the centre of the circle. If the fixed distance is 1 metre, that means I could be 1 metre away from the centre, here, 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 or here. All the possible positions build up to form a path. It's a circle with a radius of 1 metre. So, if the rule is that you're always a fixed distance away from a fixed point, then the locus is always a circle. And the point of all this, I bet you didn't know that circular loci are the basis of mobile phone technology.
That age-old problem. I'm hungry, but I've got no money. Now the challenge for my phone is, can it find me a bank? Let's try it.
Jamie's trying out a service from one of the major mobile phone companies.
Welcome to Find Me from
It can find you a bank, a petrol station, a cinema.
You are near bar.
In fact, quite literally anything.
For details on local cash points, key 1. Our search has found the following results. Barclays Bank, Cloverton Down, Bath.
Well, excellent. But I'm off to find a bank, but how does the phone know where I am?
Switch your phone on and it transmits a signal. Depending on where you are, that signal will be picked up by the nearest transmitter. This is one of the latest, and that will connect you to the phone network. Let's say a transmitter's range is 5 kilometres. So the rule is the mobile phone must be less than or equal to 5 kilometres away. Drawing this locus of points requires a piece of kit even more essential than a mobile phone. A pair of compasses. You need to use a very sharp pencil, but I'm using a felt tip so that you can see what I'm doing. On this scale, 1 centimetre equals 1 kilometre, and 5 centimetres equals 5 kilometres. I've measured 5 centimetres. The next thing to do is put the point where the transmitter would be, is to sweep a circle with a radius of 5 centimetres. Remember, the phone needs to be less than or equal to 5 kilometres away. So the locus of positions isn't just on the circumference, it's also all the points within the circle. And this region is called a cell.
Yes, it's worked, which means my phone must have been within range of a transmitter. But I'm still puzzled as to how the system knows where I am.
The system registers which transmitter picks up his signal, and from that we know which cell he's in. Now each cell is divided into thirds we call sectors, and that locates him further still. Then the system knows where all the local banks, etc. are, and it matches the two, and that gives him the information.
So how many transmitters are there?
There's about 10,000 at the moment.
It's the thousands of transmitters and their cells that make mobile communication possible, and that means we're talking about the maths of lots of loci.
The next type of locus involves a fixed straight line. The rule is that all points on the path are a fixed distance from it. If the fixed distance from the straight line is to be 1 metre, I can stand here, here, and here. These points are all 1 metre from the fixed line and build up to form a path of 2 parallel lines. At the end, the path of all the points 1 metre away from the fixed line forms a semicircle. So finally, you get a semicircle at both ends, connecting the 2 parallel lines to complete the locus. My safety is now in the hands, or should I say eyes, of Topaz. She's a fully trained guide dog. This is a weird experience. But her main responsibility is to stop me from bumping into things, which means she has to be spot on when it comes to judging distances. Come on, Topaz. Now, Wendy, you work with guide dogs, such as this little beautiful dog here. So what have they taught at guide dog school?
They're taught how to walk down the pavement, to avoid obstacles and to stop at all the curbs and really wait until the handler commands them to move on. But they also have to judge the width of gaps so that they can avoid the obstacles safely. They have to try and ignore the distractions around them. Cats running past them, smells, food on the ground, all sorts of things that, you know, they have to try and ignore to do the job.
They're just like human beings in a way, aren't they? Very easily distracted.
Absolutely.
Very sweet, aren't they? Our trainee guide dog Ashton has learned to keep herself and her trainer an equal distance from two parallel lines, the inside edge of the pavement and the curb. That means it's obeying a rule. Mathematically, it's trying to follow a path that's equidistant from two parallel lines. How will Ashton cope if I change the parallel lines to converging lines? The rule is to still be equidistant from both lines. But what path should she take? And what will the locus look like this time? To construct the locus, you need a pair of compasses. Put your compass point where the two lines meet and draw an arc which crosses both lines. Call these points X and Y. Next, put your compass point on X and Y in turn. Draw two arcs that cross like this. Finally, draw a line through the point where the lines meet and the arcs cross. This is the locus of points which are equidistant from the converging lines. It cuts the angle exactly in two, which is why it's called an angle bisector. So, will Ashton follow this path with the converging cones? Good girl, good girl. Ashton's not got any further because she's trained to stop when the gap gets too narrow. If you had her carried straight on, you'd divide the angle, eh? But you didn't know that you're an angle bisecting dog, did you? Eh? What's that you say? You're fed up with this lot now? Yeah, me too. Come on, let's go. You can even use the maths of loci to work out the location of your ideal home. Say, for example, you want to live a certain distance between two places.
Say I was a student. I might want to live halfway between college and the laundrette.
Or, if I was a top footballer, hard to believe, I know, and I wanted to live halfway between the pitch and the training ground. On me head.
To put the maths of loci to the test, I'm going to imagine a rather more glamorous lifestyle for myself. What if I were a soap star on Emmerdale? The outside scenes are filmed at a village just outside Leeds. And the inside's at a studio in town. Looks like I'd have to live in Leeds to keep up with my soap star lifestyle. So I'm off to get the lowdown on location finding from a local property expert. The rule this time is that I have to be equidistant from two fixed points. Paul, people say location, location, location is the most important thing when you're buying a house. I'm looking for a property that's halfway between the Emmerdale village and the studios. Do you think you'd be able to help me out?
I think we've got one or two things that might be of interest to you.
Oh,
and here they are.
And here they are. Oh, excellent. Let me have a look through these. Not sure I like the wallpaper on that one. That looks rather grand. It looks great, but is the location suitable? In the property finding business, 100% accuracy for the location isn't usually important because there are lots of other factors to consider. But in maths, you need to be able to draw accurately the locus of points that satisfy the rule you've been given. Remember, the rule here is that my soap star suite needs to be equidistant between the Emmerdale village, which I've marked A, and the studio, which I've marked B. That means I've got to find the locus of all the points that are equidistant between these two fixed points. To do that, I'm going to need a ruler and a pair of compasses. The first thing I'm going to do is join the 2 points A and B with a straight line. The next thing to do is to open my compass so that it's more than half AB. Put the point of your compass on A and draw an arc on either side of that line. Then put the compass on B and draw 2 more arcs to cross the first 2 that I drew. Finally, I draw a straight line through the two crossing arcs. And that gives me the locus of all the locations that are equidistant between A and B, and it's called the perpendicular bisector. So, is this luxury apartment equidistant from the Emmerdale village and the studios? Well, this is where I am here, and it's not too far from the locations marked out by the perpendicular bisector. But the question I'm asking myself is this luxury apartment really worth the luxury price tag? This is the part of the programme where Jamie and I have to do some maths for real. We're both going to answer the same question, but only one of us will do it correctly.
Yes, the other will make a deliberate mistake, which you have to spot. You decide, do you tick it or do you trash it?
Construct accurately the locus of all points on the grid which are equidistant from A and B. Pens at the ready? Let's go.
Construct accurately the locus of all the points on the grid which are equidistant from A and B.
I started by drawing a line from A to B, and I measured this distance, which is 38 centimetres. Then I marked with a small cross this point, which is halfway along the line. This point here is equidistant from A and B. To draw the locus of all points that are equidistant from A and B, I drew this vertical line here. The red line is the locus of points that satisfy the rule.
I also started by drawing a line from A to B, but in my working, the locus of points equidistant from A and B is this red line here. Now, to construct it, I used a pair of compasses. I set them at a radius that was more than half the distance between A and B. I placed a compass point on A and marked arcs above and below the line. Then placed a compass point on B and did the same again. This red line that cuts through the crossing arcs is the locus of points which are all equidistant from A and B. So whose working should you tick and who should you trash?
Was Jamie right to use his compasses?
Or was Katie right to draw a vertical line? Who made the deliberate mistake?
It's me that's wrong. This vertical line here isn't equidistant between A and B. For instance, this point on the line is much closer to A than it is to B, when I was asked to draw a line that should lie exactly halfway between A and B all the time.
The correct locus of points is what's called the perpendicular bisector of line AB. Now, you need to use your compasses to construct it accurately. And to check if your working's right, this angle here should be 90 degrees. The distance here should be exactly half AB.
It should. When you're constructing any locus, always leave in the pencil marks from your working. Don't be tempted to rub them out, because the examiner awards marks for them.
Katie, I've got this compass, but which way's north? Never mind.